Good afternoon, everybody. My name is Chris Malley. I work for the Stockholm Environment Institute, and thank you very much for giving me this opportunity to contribute to this workshop in Cambodia. It's very exciting, and I look forward to hopefully working with some of you on the development of Cambodia's clean air plan. I'd like to start by apologizing for my voice. It has improved a lot since a couple of days ago when I couldn't talk, but I hope it isn't too painful to listen to during this presentation. I would like to focus on some of the work that we have been doing in about 30 countries worldwide on linking air pollution and climate change, and how these have fed into the development of air pollution strategies. I'm going to start off by talking about the opportunity for integrating air pollution and climate change, why it's useful, and I'm going to talk about some of the results that we've achieved in countries, particularly focusing on work to develop the first national air pollution action plan in the Maldives. I'm then going to talk about some of the tools that we have used to develop the analysis that gives the quantitative numbers, the quantitative evidence to support the development of air pollution action plans, and would be very interested to discuss how that could be applied in this case to develop an analysis and an assessment of the key actions that could be taken in Cambodia to improve air quality. So to start off, air pollution and climate change are very closely linked for a couple of reasons. The main sources of air pollutants and greenhouse gases are the same, for example, transport, agriculture, different combustion processes in the residential, industrial, electricity generation sectors. And there are this group of pollutants called short-lived climate pollutants that directly contribute to both air pollution and to climate change. So by taking these actions that reduce short-lived climate pollutants, we can achieve benefits for both. Excuse me. So we know that air pollution is the world's largest health risk, but in the Paris Agreement, they make clear that achieving the temperature goals on the Paris Agreement is done with an obligation to protect the right to health. So there's a clear linkage there between air pollution and climate change. And our emission sources of the gases and particles that contribute to air pollution, contribute to climate change are the same. At the top row of this bar, we can see the sources of greenhouse gases, and each of those sources is a major source of different types of air pollutants. So we have these ability, if we focus on these sources, to reduce both greenhouse gases and air pollutants at the same time. And if we focus on climate change mitigation, there are studies that have shown that we can have substantial air pollution health benefits. So this study showed that by 2050, over 1 million premature deaths could be avoided if the Paris target is reached. So if we are consistent in meeting the goals of the Paris Agreement to limit temperature changes to below 2 degrees, we can avoid 1,000 premature deaths from the reduced exposure to air pollution that we find. And there are strategies that we can take that achieve these benefits quickly, particularly by focusing on short-lived climate pollutants. So short-lived climate pollutants are a group of pollutants. They include black carbon, which is a component of particulate matter. So it has one of the largest effects on human health through its role in forming PM2.5. They also include methane, which is a greenhouse gas, but also forms ozone in the atmosphere, which when we breathe it in has respiratory effects. So it contributes to the effects that air pollution has on human health. We have that ozone itself. It is also a short-lived climate pollutant because, as well as having effects on the respiratory system, it also is a greenhouse gas. The advantage of taking action on these pollutants is that we can get benefits for climate change and for air pollution. and they come out of the atmosphere quickly. Black carbon has a lifetime of days, so if we stop emitting it, we reduce the concentrations in the atmosphere and the exposure of people to black carbon very quickly. And we know how we can reduce these short-lived climate pollutants. The measures that we need to take already exist, and we have a decade of research showing how effective they can be. So, globally, we can reduce black carbon emissions by about 80% by focusing on 9 specific actions. Switching to cleaner cook stoves and using more efficient biomass stoves where we can't switch to modern fuels like LPG and electricity. Having more efficient burning in terms of pellet stoves and using coal briquettes instead of lump coal. In the industry sector, having improved brick kilns. I don't know if there was a lot of brick production in Cambodia, but switching to more efficient brick production can have a large effect. And having a large shift to more efficient vehicles or switching to electric vehicles and cleaning up the transport sector can also have a large effect. And in the agricultural sector, banning the burning of crop residues in the fields is also one of those measures that collectively reduce black carbon emissions by 80%. And the important thing about these solutions is that they don't just reduce black carbon emissions, they also reduce emissions of a range of other pollutants like NOx or VOCs and PM2.5. So we're not just targeting one pollutant, we get a reduction in a range of different pollutants from taking these actions. For methane, we have 7 different actions in the agriculture, oil and gas and waste sector that we can take to reduce methane to increase the air pollution and climate change benefits. And what was found in 2011 is that if we implement all of these actions at the same time globally, we can avoid 0.5 degrees of global temperature increases. And we can also reduce the number of premature deaths from outdoor air pollution by 2.4 million premature deaths per year in 2030. So we have this huge health benefit, which is likely to be an underestimate because we don't take into account indoor air pollution reductions, and we don't take into account other health outcomes like asthma attacks or preterm births or hospital admissions. They're not included in that number but would be reduced substantially from the reductions in outdoor and indoor air pollution. And reducing the exposure of crops to ozone air pollution also can have substantial benefits. We could avoid 52 million tons of crop loss from rice, soybean, maize, and one other crop that I've forgotten by 2030 if we implemented all of these measures fully. And the work that we have been doing over the last 5 years on integrated air pollution and climate change planning has been through an organisation called the Climate and Clean Air Coalition, which I think many of you will be familiar with because Cambodia is a member, and we have been implementing the institutional strengthening project there. But for those of you who don't know, the Climate and Clean Air Coalition is a voluntary partnership that looks at implementing and increasing actions taken to reduce short-lived climate pollutants. And it works through initiatives. So it has specific initiatives on those major source sectors of the air pollutants and short-lived climate pollutants. But it also has cross-cutting initiatives. So one of the initiatives is the Regional Assessment Initiative, which contributed to the work on air pollution or air pollution solutions in Asia and the Pacific that I think Kay presented on earlier. The initiative where we have been working is called the National SLCP Planning or SNAP Initiative. And this initiative provides support to countries to increase the actions that they take to reduce short-lived climate pollutants. So it provides institutional strengthening support, which Cambodia has been a part of, but also helps countries to develop national action plans on air pollution or climate change or to reduce SLCPs. And it supports these through the development of tools and guidance that can be applied by country planners, which I'm going to talk about in a moment. And it also talks about it also provides regional workshops to share experience and to share knowledge between different countries. So we have 30 countries at the moment that are part of the SNAP initiative, which have allowed us to build up a large range of experiences across these different countries because of the different national contexts and because of the different activities that they're undertaking. Some countries are undertaking national planning support. That means they're developing a national action plan on short-lived climate pollutants or air pollutants. Some countries are just doing a first assessment of SLCPs, developing a black carbon emission inventory to understand what the major sources of SLCPs are to feed into their broader planning. Some are receiving institutional strengthening support to take further actions on SLCPs, to raise awareness of it within ministries of environment and governments in general. In terms of the national planning, we have supported the development of 6 national strategies on short-lived climate pollutants or national action plans on air pollutants so far. And there are 4 or 5 other countries that will be finalising these action plans later this year. So the development of these plans has involved setting up a planning process, engaging stakeholders throughout each of the activities, developing a quantitative assessment of air pollution and climate change to identify specific mitigation measures and how they can be taken forward or what the benefits could be from their implementation in the country where we're working. We then try to identify the actions needed to increase the implementation of these actions and how they can be funded. And in some of the countries, we're beginning implementation of these plans because they have been politically endorsed. So, for example, the plan on the right-hand side here is the Maldives' first national action plan on air pollution, which was formally endorsed by the Ministry of Environment and launched by the Ministry of Transport in July 2019. And I am attending next week a series of workshops to identify how we can take forward the actions included in that plan. So I want to talk a little bit more about the National Action Plan on Air Pollutants in the Maldives. So the Maldives did not have a nationally endorsed action plan on air pollutants in the Maldives before we started working with them. So this was the first action plan on air pollution that had been developed, which is why I want to highlight it, because I believe that you are in a similar situation in Cambodia, if I understand correctly. So the Air Quality Division of the Ministry of Environment and Energy in the Maldives set up this planning process where they engaged different stakeholders to identify what actions they were taking at the moment that was relevant to air pollution mitigation, identified what actions were being taken, how much, what level of monitoring on air quality was being done by academic institutions, by others, to measure air quality in the Maldives, and then set about developing this national action plan. The first thing they did was develop an analysis to understand what the emissions of air pollutants are in the Maldives. So the graph here, the yellow line, shows the baseline emissions that they estimated. So they estimated emissions in 2010 and then projected them to 2030 for a business as usual scenario. So you can see that there is a projection because of economic growth, because of increases in population. There is an increase in emissions expected. The second thing that they identified was that the Climate Change Division, also within the Ministry of Environment, had identified specific mitigation measures in the Maldives climate change commitment, which targeted the same source sectors as the air pollution, as air pollutants come from. So the actions that have been included in the Maldives climate change commitment targeted electricity generation, targeted transport, targeted waste, which are the main sources of emissions in the Maldives. So the first thing that they did was then identify for those 22 specific actions in the Maldives, what is the reduction in air pollutants that could be achieved from implementing them. I really apologise for the coughing. What they found out was that the action plan on air pollutants in the Maldives could reduce. What they found out was that 22 mitigation measures from the Maldives Climate Change Action Plan could reduce air pollution by 35%, could reduce emissions of PM2.5 by 35% in 2030. So you could get a significant benefit from achieving the Maldives climate change commitment for air pollution in the Maldives. And that's shown by the dark green line here. This is the reduction you get from implementing those 22 actions in the Maldives. What they then looked at was, what are the additional actions not included in the Maldives Air Pollution Action Plan? What are the additional actions that could be taken to reduce air pollution further? And these were actions of having emission standards for land and marine vehicles, and they are the light green line. That's the reduction that you could get from the light green line. And when you combine them together, you get this large reduction here, a 60% reduction in PM2.5 emissions in the Maldives from taking action on climate change through their climate change commitment and through implementing these 6 additional actions. So the next step in the development of the Maldives National Action Plan to reduce air pollutants was then to identify for those 6 additional actions, because there was an existing process to implement the 22 actions in the Maldives climate change commitment. But for the 6 additional actions, to identify how they could be implemented. So they set up a process of stakeholder engagement to identify those key actions and the budget required for them to implement the actions included in the Maldives National Action Plan to reduce air pollutants. And that was all written up in this plan, which is available online on the Ministry of Environment of the Maldives website, which I can provide the link to, and was then endorsed and launched by the Minister of Environment and the Minister of Transport in July 2018. And like I say, we are now working on the implementation of that plan and identifying the actions that we can take to implement it. So that's sort of the work that we have been doing. I want to talk a little bit now about the method for developing that analysis, those quantitative numbers that show the benefits of different actions that could be included in the National Air Pollution Action Plan, and a similar process that could be gone through in Cambodia. The tool that was used to develop the analysis for the Maldives National Air Pollution Action Plan is called LEAP, which has been developed by SEI for over 30 years and is widely used for energy planning and greenhouse gas mitigation. And there are about 44,000 users in over 190 countries. But it is increasingly being used to look at air pollution reductions as well. The key features of LEAP is that it is a scenario analysis tool. So it is good at looking at projections into the future and evaluating how much implementing different policies, different plans, different strategies could reduce air pollution and could mitigate climate change. So that's what it's been used for. The way in which we work with LEAP is very much helping planners in countries to develop their own analyses. So it's not in our interest to develop analyses for a particular process or for particular applications. It's in our interest to work with planners in countries to develop their own analyses. So we try and provide training and technical support to planners in countries to develop their own models. And this allows people in countries to understand the basis for the analysis and therefore the basis for their plans, but also for it to be regularly updated so that the implementation of that plan can be tracked, and every so often that plan can be modified and updated. So the basic process in LEAP IBC is shown in these diagrams here. So LEAP is used to estimate emissions, and this can be emissions of greenhouse gases that affect climate, also of air pollutants. We develop those emissions for 3 different time periods, or 3 different scenarios. The first is a historical time period, or historical scenarios, to look at what actually happened, what were the actual emissions. The second is a baseline or a business as usual scenario. How are emissions going to change into the future if things don't change, if things continue as without any additional policies being implemented? And then to model the change in emissions in the future for the implementation of different policies, different plans and different measures. With this IBC calculator, those emissions in LEAP are then modelled in terms of their transport in the atmosphere and their chemical reactivity to estimate the exposure of people and plants to air pollution and to estimate the impacts on health in terms of premature mortality. This allows you to quantify the reduction in the number of premature deaths from implementing particular plans, particular policies, particular strategies. So to do this, this is sort of the basic structure of LEAP. So to do this, we first collect data to estimate emissions for energy demand, energy supply, non-energy source sectors. So I'm going to come out of my presentation for a moment and show you a LEAP dataset. This is for Mongolia. So they first estimated the energy demand in their residential sector. So I'm just going to use the residential sector as an example here. So they had the residential sector and they start off with the number of households. That's the activity variable in this analysis, and there are about between 700 and 800,000 households between 2010 and 2017, which is the historical period that we looked at. They then made a projection of that for a reference scenario. So the number of households was projected to increase in line with population increases out to 2030, which was the end point in this analysis. So this data was all entered here under expression using particular syntax, particular way of writing and entering this data for LEAP. So we have the number of households. That was then split between urban households and rural households because the emissions and the fuels used for different activities is quite different between urban and rural areas. So I'm just going to focus on this urban portion in this example. The urban households was then further split between Ulaanbaatar and other cities. So Ulaanbaatar is the capital, then we have other cities. This is the percentage share of households that are in each of these areas. So then we have two different types of districts in Ulaanbaatar. We have apartments, which tend to be the higher income areas, and then the Gare districts, which tend to be the lower income areas. And we have the share between the two, the percentage of households that are where people live in apartments and the percentage of households where they live in these Gare areas. Then we have different activities that take place in each of those areas. So we have heating, cooking, lighting, and other uses of areas. In the Gare districts, heating and lighting is mixed together. Then we have different fuels and technologies that are used for heating and lighting. So you have electric cooking, we have coal, we have wood, we have coal briquettes, which are more efficient. We have electric heating. For each of those, we then have an energy consumption. So how much does the average household consume in terms of coal? So a household cooking and heating with coal in a Gare district of Ulaanbaatar consumes about 2 tons of coal per household per year for cooking and for heating. We then have emission factors here for our 11 different pollutants that are being used for our 11 different pollutants that are emitted when we use coal for cooking and heating. So all of these numbers can be changed. Nothing is fixed in LEAP. It is very flexible and can be developed and designed depending on the data that you have available and the most appropriate data to be used for a particular setting. So we can just delete the data there and enter a new value. I'm not going to do it because I don't want to spoil this data set. But we can change all of these numbers for better values. And our colleagues, so the other thing I should say is I didn't develop this data set. It was developed by our colleagues in Mongolia, and we just provided some technical support. But they went through a similar process for all the other sectors, for commercial and public services, for transport split by passenger and freight transport split by different modes. They then looked at electricity generation, heat-only boilers to provide heat, looked at the energy consumption in those sectors and added in emission factors, and estimated and entered data for agriculture, industrial processes, waste, vegetation fires, and HFCs. And they did this for current accounts and a reference scenario, so they made that baseline projection into the future. But then they started to evaluate different strategies, different ways in which air pollution could be reduced. So one of the things that they looked at was, instead of using coal for heating in the Gare areas of Ulaanbaatar, what if we switch to using electricity? So if I go back to Ulaanbaatar and Gare districts and heating and cooking, and I switch from the reference scenario where people continue to use coal and wood for heating and cooking in Ulaanbaatar, switch to electric heating, I reduce the number of people using coal for heating in Ulaanbaatar and increase the number of people using electric heating. So you can see this is represented here. We have a decrease in coal consumption and an increase in electricity consumption. So we can do that for however many policies and plans and strategies we are interested in. We can represent those as discrete policies, discrete scenarios in LEAP, and then we can add them all up. So we have electric heating here. We have switching from people living in GARES in low-income areas to switching to apartments. We can add them together to give us our overall residential sector air pollution strategy. These two actions added up, what is the cumulative effect of that? Then we can evaluate that. So once we've gone through that process of collecting all of that data, and generally this data is, the data needed to develop this LEAP analysis is widely available. The nice thing about LEAP is that it can be used to develop analysis with relatively little data and using some default assumptions, and then we can build up the data set depending on what data is available and as new data becomes developed. So generally using data like a national energy balance or a greenhouse gas emission inventory is enough to get started. But if we have energy surveys, transport surveys, and information like that, then we can do a better job and do something that is a bit more detailed, like they have done here for Mongolia. The final thing that I would like to do in this demonstration is show you what happens when we click on the results button, and it does all the calculations in terms of calculating the emissions. So there are a lot of different graphs that we can show using LEAP. The first thing that we can look at is where our emissions are coming from. So I'm going to focus on PM2.5 here. And we can see that in Ulaanbaatar, in Mongolia, for the whole country, there are two major sources of emissions of PM2.5. One is vegetation fires, which is steppe fires, forest fires, release a lot of PM2.5. And the second is households, so burning of coal. And I can then change the scenario. So if I look at a reference scenario, I can see that my emissions from my emissions to 2030 are gradually increasing. I have very large amount of emissions from fires in 2015, but there is a gradual increase in the emissions from other sectors like households or the commercial sector or industry or transport, which are minor sources of PM2.5 emissions. I can then look at my different scenarios. So if I look at all of the 15 or 20 measures that were included in Mongolia's analysis, I can see that they combine to reduce the total emissions of PM2.5 in Mongolia by approximately 20% by 2030, which is not bad, but I can also see what additional needs to be done. So I need to take more action in the household sector and see if there's anything I can do about the forest fires and the steppe fires to try and reduce their contribution to PM2.5 emissions as well. So this is the type of analysis, the type of quantification that this work can give you in using LEAP IBC to do it. And I just want to finish my presentation by showing you how that was translated into a national action plan on air pollution in the Maldives. So I just want to give you an overview of this plan that was developed in 2019 and highlight what I think are some of the really interesting and nice points from this plan. The first thing that I want to highlight is that they did an analysis of the importance of air quality in achieving the Sustainable Development Goals in the Maldives. And that was a qualitative analysis, They just assessed for each of these how air pollution affects the SDG on hunger, the SDG on health and well-being, to show that taking action on air pollution has a range of different benefits. The other thing that I really like about what the Ministry of Environment did is that they then, very early in this action plan, gave an honest assessment of where they were in terms of air quality planning, which is very simple to look at and easy to understand. They have different sections on legislative framework, on the capacity that they have, on the ability to achieve funding, and for stakeholders to be involved, the ability to implement actions, and they just have a plus or a minus depending on whether that capacity exists or whether that's something they need to work on. And I think that gives a fabulous overview as to where they are in terms of air pollution action, and is very useful to monitor over time how many of these minuses can be turned into pluses. They then present their analysis in terms of the emissions of the range of different pollutants that were included in the LEAP analysis in 2010 and out to 2050. They present the national total emissions, and then they present the emissions split by different sectors. There's relatively few sectors in the Maldives, because it's quite a unique situation. There are likely to be more sectors in Cambodia, I think. Then they had some very nice graphs on how these emissions are likely to change into the future for different types of pollutants, including greenhouse gases, to highlight that link between air pollution and climate change. And then they dived into each of the subsectors to show where the emissions were coming from, for example, in the transport sector. So this graph is really useful because it shows what the contribution from shipping is versus road transport, what the contribution is from tourism, what the contribution is in the capital city, Male, the contribution from other atolls. And they do this for all of the source sectors. Then they highlight specific mitigation measures, specific actions they can take. So in electricity generation, for example, they talk about installing a specific capacity of solar photovoltaic systems, in specific areas of the Maldives. Each of the actions has a specific target and it has a timeline for achieving it. Then they show the reduction in each of the pollutants that could be expected from implementing all the actions. So like I showed in the graph, the PM2.5 emissions, if they implement everything, would be reduced by 60%. And this is the same graph that I showed during the presentation. Once they have shown the specific reduction that they could achieve, they then focus on the actions that are needed to implement them and the likely cost of these actions to do that. So to revise and set vehicle emission standards, they need to collect data, build a national emission inventory database, and use data to test the emissions of different vehicles to get a baseline to set those emission standards, just to choose one example. And then the final section focuses on those actions that they are going to take to implement this plan and to monitor it. So they talk about the institutional setup, how they are going to monitor the plan, and what the activities and organizations and timelines are for each of these activities. So I think this is a really good example of how LEAP IBC can be used as a tool within a broader planning process and planning framework for the development of a national action plan on air pollutants. And I look forward to hopefully working with you, and I'm very happy to answer any questions on um, on this work and to help to define a way forward in terms of developing the LEAP IBC analysis to feed into the development of this clean air strategy. Thank you very much and enjoy the rest of your workshop.